लिंक आपको भेज रहा हूँ यूट्यूब की लिंक आपको भेज रहा हूँ, उनको भेज दीजिए। उनको सेंड कर दीजिए व्हाट्सएप किया आपको। आप दिख रही हो लाइव में। वो लॉबी क्यों इतने जन को अलाउ कर रहे पता नहीं मुझे। लाइव है वो।
Hey, hi everyone. Are you able to hear me? But I'm not able to hear anyone.
Ma'am, you are audible, ma'am. We can hear you.
Yeah,
Hello,
yeah,
ma'am.
now I can.
Yes.
Now I can.
Sheikh sir, I request, now we can start. We have also started the YouTube live streaming, so all the participants can now join from there.
Okay. Give me a minute. Shall I start?
Yeah, please wait, madam, 1 more minute. We will share the Google Meet link to the all participants.
Sure, sure.
And YouTube link also. Please share me the YouTube link, madam.
I've shared, sir, and I'm sharing here also.
Yeah, good afternoon, madam.
Good afternoon. Good afternoon, everyone.
I think, shall we start, madam?
Yeah, I'm good with.
Yeah.
Is my screen visible?
Yes, madam.
Yeah, give me a minute. Yes, good afternoon to everyone. Hope I'm clear with my voice. Anyone confirms, please?
Yes, madam. Is it audible?
Yes, and the screen is also visible, right, in a
Yes,
full
yes,
screen mode.
yes, sure.
Yes. So let us start today's talk, that is satellite-based monitoring of air pollution. So many of you already knowing some of the basics of air pollution and the satellite-based monitoring as well. But bear with me for some of the slides which are very simple just to get the flow of the talk. Okay. So we all know air pollution is a major environmental and public health issue worldwide. Particularly India is among the most polluted countries globally in terms of PM 2.5 concentration, and we all know many Indian cities exceeds the national air quality standards, that is 40 microgram per meter cube. So if you look at the India map, Indo-Gangetic Plain completely remains the most polluted region. It could be due to dense population or emission or meteorology. There are there are ground-based monitoring networks are available, which measures the accurate measurement, but are in limited spatial coverage. So today's talk will be concentrating on the satellite remote sensing, which offers a powerful complementary approach to the observations of the ground-based air pollution. So over the large regions, if we take the satellite compared to the ground-based measurement, over the large region, we can cover it over the large regions, and also for the longer periods. That is the advantage of the satellite measurements. So today, next 45 to 50 minutes, the outline of my talk will be, it includes the satellite monitoring of the pollutions, and also I focus more on aerosol optical depth and PM 2.5 and some of the popular model approaches which researchers are using to get the PM 2.5, that is particulate matter 2.5, and also I'll show some of the demonstrations uh, how we can download the data, satellite data for the air pollution. Yeah. So just to start with, the air pollution refers to it's a presence of harmful substances in the atmosphere. We know there are many sources of air pollution. As you can see in the screen, it could be from the natural emissions or from the other household, agriculture, waste management, transport, and industrial pollution. These are the many different sectors where the air pollution is contributed. The major air pollutants are the PM 2.5, PM 10, nitrogen dioxide, sulfur dioxide, ozone, and the carbon monoxide. Among these, particulate matter 2.5, that is the particulate matter with an aerodynamic diameter of 2.5 micrometer or still smaller. So it is something like it's about 30 times, it is 30 times smaller than the width of the human hair. So you can imagine how small it is, the 2.5 micrometer, and can remain suspended in the atmosphere for longer periods. That is a problem with the PM 2.5, and it is harmful because these are the fine particles which can penetrate into the lungs and to our bloodstreams also. So this is one of the criteria pollutant which we need to monitor continuously. Continuously, yeah. So going to next slide, why we should monitor air pollution? Definitely, there are several reasons. As we all know, we should monitor this pollution, which is very important because first and foremost, it has a lot of health issues. Exposure to the air pollution can cause the respiratory diseases. Even many researchers have proved that cardiovascular problems and even the premature deaths also happening due to the air pollution. And definitely along with the health, it impacts the environment as well. And also monitoring helps to identify areas with high pollution concentration. By doing this, government and also the public can get some policies to have some identify some after identifying the some pollution hotspots based on the data. Definitely, it can support the policy and regulation. So it is very important to monitor the air pollution. So coming to the basics of remote sensing, satellites are all remote sensing instruments. Definitely, it collects the information about an object without an object being in direct physical contact with it. Yeah. So that's how the satellite measures the air quality or any other data set. When you look at the remote sensing platforms, there are different platforms used for the remote sensing. So you can see the satellite, and you can see the balloon based measurements, and also aircrafts, and also the ground based measurements. It can be mobile or fixed. So there are several different platforms where we can do the remote sensing. The remote sensing technology can be applied. So the choice of this platform depends on required spatial resolution. Which resolution you are looking for? You are looking for the entire Indian region or a global. Definitely, you should go for the satellite. If you are looking only for the limited region, then with a continuous monitoring, like every 5 minutes, every 1 minute, then you should go for the ground-based measurements. And the aircraft and the balloon measurements are something like covers a small region, but still the global coverage, if it comes to a global coverage or a larger spatial region, definitely it is recommended to go for the satellite-based measurements. So this is a small introduction about the remote sensing of the platforms. So each platform has a different spatial and temporal resolution, as I said. And coming to the advantages, definitely satellite monitoring has a lot of advantages. In fact, in India, people are not compared to other countries. Still, the satellite monitoring usage need to be increased. So there are several advantages of this satellite monitoring. One is the open access data set. Data set is available freely. You can download the data and has a global coverage. Whenever the data that represents the observation of, we can get the from the locations all over the world as well, and has a high spatial resolution data that provides detailed information for very small geographic areas also. If you are looking for particularly for some states or districts, definitely it can give the information about the small geographic areas as well. And best part of it is continuous observations. Measurements are collected regularly over time without any large gaps. So that is the advantage of the satellites. With it can have the continuous observations as well. And the data is gridded, that is organized into evenly spaced grid cells covering a geographic area, and which is very useful for the this satellite monitoring is very useful for the regions where we don't have a monitoring stations. That is the best part of the satellite monitoring. So wherever we have a limited measurements, like example in case of air pollution, most of the ground-based instruments are located in the urban areas. Very few in the rural areas or the semi-urban locations. So definitely these satellite monitoring will be useful where the measurements are ground-based measurements are very scale less. Yeah. Coming to the important satellite missions, there are several satellite missions widely used for monitoring the air pollution. Just I listed few of them, very important ones. And you can see the first one is the MODIS, that is Moderate Resolution Imaging Spectroradiometer, which provides a long-term data. You can see it is a NASA's project which is on the Terra and Aqua satellite, and the data is available from almost 26 years. You can see Terra is from 2000 to till date present, and 2000 Terra Aqua from 2002 to present. And next, the visible infrared imaging radiometer suite. That is the collaboration with NASA and NOAA, And that data is also present from 2011 to till date. And there is a one more interesting, this is this Calypso, the cloud aerosol lidar with orthogonal polarization, which is active remote sensing, which uses the LiDAR technology to provide the vertical profiles of the aerosols as well as the clouds, which will help to understand the height and distribution of the pollution layers as well. So, but unfortunately, it is concluded in 2023, but data is available from 2006 to 2023. And next is the TROPOMI, the tropospheric monitoring instrument, which is on Sentinel 5P, and the data is present available from 2018 onwards. And the ozone monitoring instrument, which is OMI instrument, which is on Aura satellite. The data is also long-term data is present from 2004 to till date. Yeah, these are the important satellite missions which people regularly uses for the air pollution monitoring. There may be few others also. I just read the popularly people researchers which they use. Those things I have listed here. And coming to the, as I said, the major satellites for aerosols and PM monitoring, that is particulate matter monitoring. You can see as I said, MODIS, which has a 26 years long data set, which measures the aerosol optical depth, which has a two on it, it is on board two satellite Terra and Aqua both, and which measures the aerosol optical depth, and has the, and also it has a global coverage for every 1 to 2 days. In only in few places it is 1 to 2 days. Otherwise, it is available coverage is daily global coverage for Indian region, and it is widely used to estimate the PM 2.5 concentration. So the MODIS is the one which is used to measure the PM 2.5 concentration, which is the air pollution criteria pollutant. And next is the VIIRS data, which measures the aerosols, fire counts, and the atmospheric particles as well. And little higher spatial resolution it has compared to MODIS, almost around 750 meters. Whereas the MODIS has, for particularly aerosol optical depth, it is 1 kilometer spatial resolution, whereas VIIRS data it is 750 meter spatial resolution. This data is also daily global coverage. And coming to the Calypso, which is what which gives the which is a LiDAR technology and provides the vertical distribution of the aerosols vertically from starting from ground to up to the stratospheric regions, and which helps to understand the aerosol layers and the transport as well. So this has the horizontal resolution around 5 kilometers, and the vertical resolution is just a 30 meters up to 60-meter resolution the Calypso has. So these are the major satellites for measuring, monitoring the aerosols, and this AOD can be used to calculate the PM 2.5 concentrations. Coming to the satellites which monitors the trace gases. These are the one with these are the not only the ones, but I listed the popular ones. The Sentinel 5P. This is the ESA on a Copernicus, and the instrument is TROPOMI, as I said. And this measures the nitrogen dioxide, sulfur dioxide, carbon monoxide, methane, ozone, and some of the aerosols. So this is the best satellite monitoring for the gas, which covers most of the gas pollutions, and the coverage is not that compared to the not good that compared to the MODIS. It is around 3.5 to 5.5 kilometer spatial resolution, but it has a daily global coverage as well. And the OMI satellite, which also measures the NO2, SO2, and ozone, and also aerosol index as well. But the resolution, spatial resolution is not that good compared to Sentinel 5P. OMI has a resolution, spatial resolution of 13 by 24 kilometer spatial resolution. Whereas there is one more satellite, that is a GOSAT, which measures the carbon dioxide and the methane as well. This data is also available And this is a little or almost 10 kilometer spatial resolution. So particularly this OMI and Sentinel 5P are used to more focused on the aerosol pollution gases, whereas the go-kart, which measures these are the greenhouse gases, right? So it measures the greenhouse gases, but definitely they are high spatial resolutions, daily global coverage. This is best advantage, and urban and regional analysis can also be done with using this. The key applications, definitely aerosol quality, air quality monitoring is done very well using these instruments, and emission tracking we can do, and the climate change studies can also be done. Definitely these data based recommendations or the policies definitely will lead to the great changes. Yeah. So these are the ones. Just everybody may be knowing this, but thought it is good to tell what exactly the satellite measures. It doesn't measure directly the aerosols. It measures just the radiance actually. So here the sunlight as a radiation source. Solar radiation reaches the Earth surface, and the Earth surface has different surfaces. It could be a built-up space, paved roads, grasslands, water, or a forest. So it interacts, the radiation interacts with these surfaces, and in a different manner. And it radiation is scattered or reflected back towards the atmosphere. It is scattered back to the atmosphere, and there are some detectors in the satellite which will detect the signal, that is the radiance in radiance. So the whatever the signal is measured is not directly it is in terms of radiance, and then the experts will apply some algorithm which converts the radiance into aerosol products. It could be aerosol optical depth and other aerosol products. This is how it is measured. So most of you may be knowing still. I thought it is good to show one slide on this. And coming to the satellite image, here you can see this is a one satellite image from the Modis Terra, which is taken in 2007. Just a sample I have kept. This is a true color RGB color composite image. You can see these. There are different features. You can see the land and the water and the smoke. You can see this is the smoke, and this is these are the clouds. So when you look at the RGB composite, these are the different landforms, or you can say different atmospheric features we can look into. So if you look at the land surface, it is brownish and a greenish in color, and the water bodies are little darker. So this is just a RGB color. But this later we need to the images are later applied some algorithms to have the aerosol product, something like this. So the radiance to aerosol product. This is the aerosol product. I can see here. You can see here the high values. You can see these are the high values. Though those are the high values which are having the higher aerosol concentration. Here they applied some algorithms where from here to here it is converted radiance into the aerosol products. These products are useful for us. This they do in build already. This is done and this is given, and from here we need to take it ahead. So these are the aerosol optical depth or aerosol concentration, and the low values you can see here. The high values are the red patches are the higher concentration of aerosols, and you can see the lower ones. You get the blue ones, which are clearer, little clearer atmosphere. These are the moderate ones, and there are no retrievals also. That could be due to presence of cloud or surface reflection. Many reasons. So some retrievals are not possible. So after applying the algorithm to the radiance, and these are the aerosol products what we are getting from the satellite. So now the challenge is, now what we are getting is the aerosol optical depth, as I said, from the satellite. So now the challenge is we need to convert into a air pollution, that is, which is measurable at the surface. That is the particulate matter. It is a surface concentration, which refers to the airborne particles with the aerodynamic diameter of 2.5 micrometers. Okay, so this is actually a challenge, converting the aerosol optical depth to PM 2.5. whereas aerosol optical depth is a columnar integrated value. It is the optical measurements which covers the entire column starting from the surface up to the satellite height, whereas the PM 2.5 is the surface measurement. So this is a challenge we need to researcher has to undergo in order to get the measured satellite AOD to PM 2.5. One more figure is there with me, which will give you a clear understanding what is our interest and what we are getting from the satellite. If you looked at this figure, you will understand much better. You can see this is the atmosphere and this is the top of the atmosphere where the satellite is flying. And this is the one, this you can see the dark yellow one. That is the one which the satellite measures. It is a 10 kilo per kilometer square vertical column it measures, but what we are interested in is only this much, which is at the Earth's surface. That is the PM 2.5. That is the mass concentration. Whereas this is the total columnar aerosols present starting from surface to atmosphere. We are interested in this. So we need to, from this, we need to calculate these values. Here is the challenge and the researcher's expertise lies. And coming to the, this is very important to understand the aerosol optical depth and PM 2.5 relationship. So they are related something like the relationship between the aerosol optical depth and PM 2.5 is influenced by many of the parameters. Some are physical and atmospheric parameter. Can see it is influenced by the particle density. It is influenced by the extinction coefficient, that is the amount of absorption which happens in the radiation, and also the effective radius of the particular particles. If example, if the dust, it is a large particle. So if the particle is larger, it contributes strongly to the AOD, aerosol optical depth. Whereas it may not contribute that high to the PM 2.5. So those challenges are there. And also the percentage of bound aerosol present in the planetary boundary layer, and also mixing height are also important. If the mixing height it is high, then more of the pollutions are concentrated below. Below the pollutants are trapped near the surface, something like that. So these are the information we need to understand to give a relationship between PM 2.5 and AOD. But these informations are not available as such. So what the researchers are doing is they so we use some satellites. AOD must be combined with the additional predictors to estimate the surface PM 2.5. So what the to estimate this PM 2.5 from the satellite data, researchers use both statistical models as well as the machine learning models. So different models. Statistical are very simple models which will capture both linear and non-linear relationship. There are several like simple linear relationship between the aerosol optical depth and the PM 2.5, and also multiple regression by considering some of the meteorological parameters like humidity, temperature, or a pressure, or a wind speed and direction, which will impact the PM 2.5 and AOD relationship. And those can be introduced in the multiple linear regression model. And also generalized additive models can also be used. Some researchers have used mixed effect models and geographical weighted regression models. These are the statistical models which one can use to understand the relationship between PM 2.5 and AOD. Then we can estimate the PM 2.5. And also nowadays the machine learning models are proven very good compared to satellite models, because they handle a non-linear relationships as well, the complex non-linear relationships as well. So they incorporate multiple predictors also within the machine learning models. And compared to the statistical models, definitely the machine learning models have proved a better prediction accuracy as well. So this is how the from AOD, aerosol optical depth, which is measured by the satellite, we are getting estimating the PM 2.5 values from using the any one of the model we can use and get the estimation of PM 2.5. Yeah. So this is the framework actually. So whatever I explained now, this is a framework how the workflow, how it goes. First, the satellite measures the data, that is aerosol optical depth retrieval, and then the ground-based measurements. We should have some ground measurements as a predictors, that is PM 2.4 monitoring stations, and then the meteorological data is included in that, temperature, humidity, boundary layer height or pressure, wind speed, wind direction, as I said, and even the cloud cover and NDVI also sometimes researchers have used as a predictor to understand the relationship. And then it goes for the model development. Then you get the output of the high resolution PM 2.5 estimates. This is how the we get the here is the researchers challenges lies how you we get the satellite data in terms of aerosol optical depth and how we get the estimate the PM 2.5 values. And here are the to understand here are the already published references I have given. These are the, you can see this the first figure which is from the machine learning model. This is, I think, neural network neural network model has been used, and they have done the spatial mapping of PM 2.5. You can see of 1 kilometer by 1 kilometer pixel size. You can see very nice. And this is a one more model. This we have done actually. This is a statistical model we have used, and this is for Delhi NCR, complete NCR. This is a Delhi NCT, and this is for entire Delhi NCR region. You can see the variation of, and this is the annual PM 2.5. So here in Delhi NCR it is very polluted, and whereas here it is little bit better. So this is how these are the maps, spatial maps we can get from the satellites. Once we do those, apply those models, any of the model, and then go for the spatial maps. So this is how it is done. So next, coming to the, this is really interesting, and you all may be curious how we can access this data or download the satellite data. So you can see satellite data are freely available, as I said, and they can be used for the atmospheric research. And there are different platforms actually which provides the access to the remote sensing data. And common formats includes the NetCDF and the HDF data sets. And I'll discuss today in today's talk. I'll discuss the three common approaches most of the researchers are using to download or the access this data set. This will be helpful for the beginners and also for those who know some extended versions methods are also I have added in this. So for them also it will be very much useful. So I'll discuss three common approaches to download the satellite data and to access the data. And the first one is very simple one actually. You can get this method is very user friendly, which is developed by NASA. It is a NASA Giovanni. It is a web platform actually, very user friendly web platform just to visualize and also to download the data. And here is the website. We can go and download the data. And you can see there are this is just a snapshot I have added here just to have a feel for it how you can download the data. You can select what kind of plots you are looking. It is time average, many different plots are available. You can try with it, and you can select the data ranges also, which data range you are interested. If you look for the Moody's, it has 26 years of data, and the data straight away available in this as well. And you can select the region also, which region you are interested in. Here I have selected the Indian region, and there are several variables also you can select here. Which observation you want, the observations or the model, or you are looking for the aerosols or some other products. I selected the aerosols, And also I'm looking for the aerosol optical depth because we have discussed just now the AOD. And the platform, you can see both, you can Aquaterra, you can get, there are some other platforms or instruments also available. You can go for it. And the spatial resolution you are getting is 1 degree, not 1 kilometer in this actually. That is the disadvantage, 1 degree, but always you can play with it and see, you can feel for it, how the satellite data look like if you are a beginner. And you can have a temporal resolutions also. You can go for the daily or the monthly, it will combine the monthly data as well. And wavelength, of course, you can choose. And there were some other radio buttons also you can try for. After selecting this, you can see it. I selected only for the aerosol optical depth. So you can see all our aerosol optical depth related, AOD related um, data sets. From the MODIS Terra, I selected only MODIS Terra, and daily, monthly data is also available. And all are with a spatial resolution of 1 degree. It is huge actually. We cannot get the 1 kilometer data in this. And some ranges I have selected here. So it is showing the range of the data. So after giving this, I mean, after getting the plot data, just one map I have added here. You can see this is the one which the Giovanni directly, the data is given. You can see this is the averaged map of a AOD at 550 nanometer for the land and ocean both. You can see this. This is the 1 degree resolution data. And this is the aerosol optical depth scale. This is for 1 month actually. You can see the date 2025 January whole month I aggregated. This is a monthly mean aerosol optical depth over the Indian region. So this is how it is, very easy to run. Only thing is you should be very careful in choosing these radio buttons which you are looking for, and then get the plot the data. So this is how the first and the very easiest method many researchers are using. And if you are a beginner, as I said, you can play around and have a feel for it, how the satellite data look like. And also not only images, directly this image can be downloaded in the JPEG or PNG format. Even the data is also available. You can download this data. It is a gridded form and you can plot in some softwares which you are familiar with. That is also possible in this. Not only spatial maps, you can get the temporal maps also. If you're looking for the only Delhi region, only for some location, this only Delhi for some location for entire 1 year. That temporal maps are also available in this web-based application. So you can anytime you can play around and get the feel for the data set, satellite data set, and then go for the next methods which are where you can get the better resolution. Like example, second method, it is a direct download from the data portal itself. I added two portals here. The first portal is for the NASA, the MODIS data, where you can download uh, the first one, Landsat, and the second one is the ISRO also recently getting the data for the AOD. Similarly, 1 kilometer resolution. These are the higher resolution data we can directly download actually. So these are the download satellite data from the official portals. These are official portals. You can note it down and you can download the data. And many of examples, these are all data sets are available. And the format of the data, I think many of you may be knowing already as a researcher, the HDF data and the NetCDF data. There are many softwares we can use. I can process this data using the MATLAB or the Python or the R, any of the, or sometimes GIS platforms are also used to process this kind of data, the NetCDF and the HDF data. Only advantage in this is we can get a higher resolution data compared to Giovanni. Giovanni is the 1 degree resolution, whereas in this we can directly download the data from the portals and get a higher resolution of 1 kilometer or below. Yes, if it is available. That is the advantage. So when you go for the method two, when you go download, just I have pasted one snapshot. This is for the MODIs, particularly for the aerosol optical depth, something like this. It is a gridded data. You can see these are the tiles actually. If you select one tile, you can download. This tile you can download, or this tile, if you're interested, you can download. That part only the data will be downloaded. And this tile is size of 1200 by 1200 kilometer size. And from there you can see you can pick up your region of interest, then processes. This is tedious, but really worth doing if you are good in programming language skill sets. So this is how it is done. So these are the tile wise they have kept. If you take the India as a region, it covers 1, 2, 3, 4, 5, and 6 or 7, some part here. So these are tiles you can download and then merge those things, and that can be done very easily, and download the data. And higher resolution data you can get it from this kind of portals. This is one snapshot. And there is a one more method that is really interesting, and it is very close to my heart as well. And I started exploring this as well from the last 2 years. So this is a third method, that is Google Earth Engine. This is very advanced actually. And as a researcher, if you are a beginner, definitely you look for this, and it will save a lot of your time. So this is a website. This is you can see this is the website where you can get the editor. It's a cloud-based platform. The best advantage is you need not download the data at all. If you go for the previous slide, if I go for this slide, if you download this one tile data, it is huge size. It all depends on what number of variables you are downloading, but still the data is huge. A per day satellite per day data is around 50 MB. It can go up to 120 MB. If you are downloading a year data, it will be completely full your hard drive, hard disk. So that is the bad part of it. So the best part of it in this Google Earth Engine is you need not download the data at all. No larger data downloads are required. Definitely. And satellite data are stored in cloud platform actually. So users can analyze the data without downloading any data. So that is the best part of it. And they can access data sets, any data, many data sets are kept there. The MODIS is there, Sentinel 5P, Landsat, VIIRS data, OMI data, whatever we discussed right now, all the data sets and many more are already added in this platform, Google Earth Engine. And it is a multi-agency platform. It is not limited to NASA only. NASA. It is the NOAA data is also present. Many other data sets are also present in Google Earth Engine. Try to explore this opportunity. And it is a JavaScript. You can use the directly when if you are writing the Google Earth in Google Earth Engine itself. There is a code editor available. You can write the JavaScript there itself, or if you are good in Python or R, there is an API for it. You can always try this option as well if you are not good in JavaScript. And it is suitable for the large scale environmental analysis also. Definitely, it's a fast processing, a big data. The best part is you need not download the data, and you can write the code. It's a cloud platform, and everything will be done very fast actually. Only thing you need to register. Registration is freely available. You have to register and just get this code editor and start exploring. I have done one simple image. You can see here. This is the Google Earth Engine. This is how the code editor look like. Just I try to explore the NO2 concentration, NO2 columnar number density. I downloaded just for 1 month, just to have a feel for it. You can see I plotted this for the our Indian region. You can see NO2 column number density, very high concentrations are here, Indo-Gangetic plains, and some part where the coal-based thermal. After writing, you need not go anywhere to plot it. It immediately plots here also, and you can have a feel for it. This is the best part of the Google Earth Engine. And otherwise, downloading one part and then going and plotting in analysis is one part. Everything is done right away here, and within a very quickly it is done. Only thing is you should know how to write the JavaScript and how to vary what are the variables, and some programming skill set you should have. Then definitely this is the best and recommended method according to me. and you can always explore this one. So you can see this beautiful 1 month averaged NO2 concentrations over Indian region. Yeah. So some of the key conclusions, we have seen the satellite remote sensing enables large scale monitoring of air pollution. And we have seen we have AOD can be used to estimate the surface PM 2.5. And there are platforms such as we have seen the Giovanni. If you are a beginner, you can right away start and explore how it is and you can feel for it. Then go to the data portals you can download and feel how NetCDF and HDF data look like. But most recommend is the Google Earth Engine. Now it is available from last 4 years. You can use this and Google Earth Engine, and which is efficient to access the satellite data sets. And satellite observations support the air quality monitoring and environmental decision making. These are the data driven satellite, whatever we get from the satellite or the ground base, these are the data driven researchers. So definitely they'll go for the policy and the decision making, especially the regions where the limited ground measurements are available. So these are the main key conclusions or takeaways from the talk, and we'll be very happy to address some of the questions and discussions, if any. Yeah. Thank you. Thank you for your patience. Any questions?
Hello, madam.
Yeah, please.
Very good presentation, madam. Actually, different satellites are there. No, what is VIIRS? But what is the difference in the quality of data will be difference will be there, depend on satellites.
Sorry,
Quality of
I
data.
didn't get you. I didn't get you. Please
No,
come again.
please, the different sat mode is VIIRS and Calypso, OMI, different satellites are there. So the data might be, the data quality might be different based on satellite, based on these satellites are all are same.
No, not all are same actually. So they complement each other. You can see, 1 second. So if you go to, 1 second, give me a minute. So if you go for the Modi's, VIIRS data and the OMI or the Sentinel 5P. So all measures are different actually. If there are many research, if the example I'll tell you, ISRO data, ISRO also started giving the AOD data, right? And Modi's also gives the AOD data. Initial comparison has been done with both the instruments, the AOD and AOD, both are comparative. They're almost the same. So it's not that difference. So this is what you are asking?
Yes, actually.
Yes. This initial experiments before giving out the data, they do these things. They compare. Even they compare the satellites once they are flown. They compare that data with the ground-based measurements also. Not only ground-based aircraft measurement, many measurements they'll do, and then they compare. Then they give the different levels of data, like beta versions, and then the final versions will come to the public for the researchers to use.
No, is it compare all data modis and VIIRS Calypso consolidated?
If the product is same, if the product is same, definitely you can compare and have one paper, one research article on it. Definitely.
Yes, actually, I need one parameter data. For example, such data required for me.
Yeah.
So which satellite
right
can be used?
Yeah. Right away, you can start the ISRO's AOD and the Modi's AOD for particular region. You can start exploring it. Because ISRO gives only for the Indian region, whereas the NASA's Modi's gives for the entire global. You can always compare that data just to kickstart. And many things you have to do, but this is a good start if you are a beginner in the research
Yes,
field.
for Saturday I am beginner. Actually, institute observations I have done. Actually,
Okay. Yeah. You can always do this. Yeah.
Thank you. Very nice.
Yeah. Any other questions? You can directly shoot the questions here only.
Excuse me, again, one more question, madam, please.
Yeah, yeah,
Uh,
please.
which is at the high resolution will be there, madam? Actually, the modest VIRS, which is high resolution measurements will be there, which is
Mode is currently 1 kilometer by 1 kilometer. That is the highest resolution for the aerosol products, aerosol optical depth. And VIIRS data, it is 700 meters, but it doesn't have a AOD. It has a fire counts and other things. If you are asking me for the AOD, definitely the MODIS, that is MIAC data, which combines the both Terra and Aqua. It is 1 kilometer by 1 kilometer resolution. Spatially and temporally, there are two satellites, right? One is Terra and another is Aqua. Terra overpasses in the morning time for the Indian region and Aqua passes in the afternoon, right? And there are two overpasses in a day. For MODIS, there are two overpasses in a day. One in the morning around 10:30 and the afternoon 1:30 to 2:30. There's the Aqua overpass. So we have a two overpasses over the Indian region. For the MODIS, then that is the one which is the higher resolution 1 kilometer by 1 kilometer. Even the ISRO's AOD is also 1 kilometer by 1 kilometer. Yeah.
okay. Actually, thank you, ma'am.
Yeah. Yeah.
For example, one more thing, madam. Actually, if everybody is okay for environmental parameters, other parameters also there. No, actually, for ocean surface like this. For this
Yes.
also, what is for this observation also, it is good for modis.
You're asking only in MODIS or some other data sets. If it is in MODIS, there are not only aerosols you can study, there are cloud parameters also you can study. NDVI is also available. There are many, many other parameters available. MODIS is not only limited or restricted to the aerosols. As the talk is going only for the air pollution, so I limited myself to aerosol optical depth. So if there are cloud water vapor is available, cloud cover is available, cirrus clouds, which are high level clouds, that information is also there. There are a lot many things are there in MODIS, but just I picked the one, the AOD, that is because that is representative of the PM 2.5, which we are interested because that is the air pollution which is causing, right? So that is the reason I only focused on aerosol optical depth from the MODIS. Otherwise, there are huge and huge variables you can play around and understand along with the AOD.
Actually,
Yeah.
I want actually working as a oceanographer. I am oceanographer. See parameters like instead of observations I have done. Actually, satellite data also I would like to process data. That's why
Okay.
asking this question. Actually, for
No.
surface seawater observations, which is satellite is more better, man.
Sorry, come again.
For seawater observation, ocean observations, for ocean parameters, surface parameters,
Yes, yes.
which
They are also available, right?
so,
They are also available.
that is available. I know sea surface salinity and also pseudo and other parameters also there. Water quality parameters. So, but also which is can you suggest, madam? Which is good
The
resolution?
C parameters, I'm not much aware of it. But which platform you are using to download the data and analyze the data? Are you using Google Earth Engine or the old method?
I am newer, madam. Actually, I am institute observation side. Actually, I started the first time only. That's why institute water quality parameters I have done. So for satellite measurements, I want out.
Okay,
So
okay.
I can use Google Earth Engine.
Okay, but I'm so sorry. I'm not into the sea related variables, ocean related
Okay.
variables. I'm not that good at. But definitely aerosol optical depth or other parameters. Definitely I can help you out.
Okay. Thank you. Thank you. Actually.
Yeah, yeah. So any questions, please? Those who have joined all are from the air quality or air pollution background or some other backgrounds also.
No, other background also, madam. Actually, this is
Okay.
common for all environmental. Some town planners is also there, engineers also there, assistant professors. There are students,
Okay.
MSc students, research scholars.
Okay. Good take on
Actually,
that.
they are not joined our group, but they are in the stream in the YouTube live stream. They are joined in the
Okay.
YouTube live stream because of
Oh,
there are huge number of registrations are done. So almost all
oh,
we have reached the more than 4,000.
oh, good, nice.
So that's why we only the particular means only few people first come first join only we are joining and
Hmm.
others are in the we are given to the YouTube live stream.
Okay. Okay. Do they have a chance to ask? No, right? YouTube streamings, they don't have a chance to ask the questions.
They don't have a chance to ask the questions. They can, I think, they can post the questions in that chat box there
Yes.
inside.
Okay.
So, but
Yes.
that
Yes.
also we have to go with the YouTube link and we have to answer them.
Little tedious it is, right?
Yes, ma'am.
Yeah. Yeah.
So anyway, we will we are trying to do the join and more people for the instead of 20 and 30. We are planning to conduct in the joining to the more than 100 or like that.
That helps actually.
Yeah.
That helps. Yeah. Yeah. So any other questions, please? Thank you, Gautami. If you have any questions, please.
If there is no other questions, then we can leave me. Yeah, from IITM Pune side, somebody?
Satish Kumar, you have some questions?
Okay, then we can leave, madam.
Okay.
So, okay, thank you for giving a wonderful lecture for the concepts of air quality,
Yes.
satellite
Yes.
applications in air quality.
Yeah. You can
So,
drop my email ID, Darga, if anybody is interested to
yeah,
get
yeah,
any
I will
information.
share,
Definitely.
yeah,
Hmm.
in this group, I will share to your in mail ID
Yes.
and
Yes.
yeah, sure.
Yes. Definitely, it will helpful for the researchers who are just started the satellite data exploring. We know how tedious it is
Yes. It is
start.
very now very
Yes.
hot topic in the air pollution is a very hot topic. Particularly in the instead of measurement, they are going to the satellite measurements are very useful.
Very useful it is. Actually, as
Yeah,
I said in my talk also, in India, very less compared to other countries, although the data is available, but still if it comes to the air pollution, very limited data has been used from the satellite. Definitely, we look forward, and even also interested. I'm involved in doing this activity actually since long time, 5 6 years, only to on dedicated on satellites. So
yes,
we use less satellite data for the air quality measurements. So more and more research scholars have to come up and take this ahead actually. That is
yeah,
much more needed.
that is more than 20 years data is available, is right, madam?
Yes, the 25
More
years
than
data
20
knowledge
years.
data. Yes,
Yeah,
yes,
even though for the validation of the satellite data products, there are 20 years data is also available from the that one Aeronet site.
yes, Aeronet sites is available. Yes, yes.
Yes. So there are a lot of scope is there to study the satellite data.
Yes, there are a lot of scope, but only there are some limitations when we use this data, aerosol data, satellite aerosol data. There are some limitations actually also are there. I'll not say it is straight away we can use. There are certain limitations like if you have a large cloud coverage, the aerosol parameters we are not going to get, especially during the monsoons. Okay, so the cloud data, AOD data is not available from the MODIS data. Very few regions it is available. So there are challenges, but still we can have a lot, many studies can be done using the aerosol products from the MODIS or other products, Sentinel, NO2, SO2, ozone related studies.
Yes.
Many studies can be taken up. And nowadays, as I said, the Google Earth Engine is a very well known platform for many of the researchers, and we can explore many of the things in that.
Yeah, sure. So thank you.
Yeah. Thank you so much, everyone.
Thank you to everyone.
Yeah.
So shall we leave? So we will meet same time in the tomorrow.